Aloha, this is Richard Halverson, and I had my headphones off. um, and this is ITS128, and today is November 19th. And let me share my screen. And we are in this week, Thursday, and today we're going to start Chapter 8, Lists and Dictionaries. And we're probably going to do a few of these challenge activities. And I guess next week is Thanksgiving, so we're only going to have Tuesday. Okay, well, anyway, so here we are in lists and dictionaries, and lists are called arrays in other languages. A list is an array, and a dictionary is an associative array in other languages. And you'll see what these mean here. Let me get my chat. And all right. So a list is like a container, and you can put a more than one number in the container, or it doesn't have to be a number. It can be a string, more than one thing, and you put them in an order, and then you're able to access those elements of the list by their index, and you're able to modify the list and modify each element, and you're able to sort the list pretty easily, and all of that. So here's an example of creating a list called my list, and it's got 3 elements in it. It's got the first one is a string, the second one is this negative number 4.2, and the third one is this integer. And so it creates an object thing. It's got an object name and 3 additional containers to store the elements of the list. So here this explains about the index, and okay, let's do this one here. So we have this this list called oldest people, and it's got 5 elements in it, and it's got a list of the okay, and it looks like it's ordered where the first one is the oldest, and the second oldest, third, fourth, and fifth, and it asks you a number like the third element of the list, or the third oldest, and it will print out this is the oldest people, and here you are referencing the third element. You're referencing the third element, but the element numbering starts at 0, so that's why you have to subtract 1 from it, because it's index number 2. There's index 0, index 1, and index 2. And so you run this, and it's going to figure it all out. This is the question it asks. This is what you enter. And then it says the third oldest person lived 117 years. Okay. All right. So now in this little exercise, you're supposed to fix it. So instead of it saying the 3rd, it should say the 3rd. So the first and the second and the third should change, and the fourth and the fifth can be like this. So that's pretty easy. You just and the point here is you're getting the exercise in indexing the elements of the list. So let's do if the nth person equals 1, in other words, you want the first element of the list, then the first oldest person lived that. This is fine. And then we can do, we could actually just leave it this, no, okay. Okay, this, the second one, we need a 2. The second oldest, because that's the only one that has ND. And, oh, I guess we're going to need 4. Oops. Third, and then fourth and fifth. So this is first, second, third. Oh, and this is a 4, and this is fine the way it's written like that. All right, so now now it should say the right thing. Now some people might argue that a more efficient way of writing this would be have this be elif, because these are all mutually exclusive. And then you wouldn't even need, and then this here could just be an else. That'll work too. But anyway, all right. And here you're just practicing indexing. This would be cat. This would be bird, so on. Okay, here's common operations. Here is how you might create a list with elements 1, 2, and 3. So you create it, and then you print it. It's going to look like that. This creates a list, but this is not an assignment statement. This is an expression. So you use it like this. See, so this does the same thing as this with the data, but this is actually an iterable object, which means you can iterate through this, and the string is an iterable object. So this creates a list out of this iterable object, and so that's ends up being the list in there. And so creating this is the same as creating this. Oh no, these are strings. These are actually numbers, values. So that's why there's no quotes around them. But these are strings. So it's characters of a string. All right, and here's how you reference an index. The indexing works the same way as with strings. So you can do a start and an end, just like this. And you can append one list on the back of another, and you get a new list, just like with strings. You can change the value of an element in the list like this by having, you're assigning a new value to this element. So you're assigning it the value x, whatever x is, like this. You can. This is one way of appending onto the end of a list. It's basically you're appending this, and this can be a list, onto the end of your list, starting with the the next available one. If the list has 5 elements, then the elements that are in there are numbered 0, 1, 2, 3, and 4, and 5 is the first index that doesn't, where there's not an element. And so, and that happens to be the length. So this references the that index number 5, which is where you would stick it on. And then the fact that it has colon and then blank means in case this is a list, you want to do as many as there are in the list. So, but you can also use append, and that's what most people use. All right, and then you can delete an element in your list by just like this. All right. So here's some examples. You can
I
go.
have a quick question.
Yes.
Does X sometimes cause errors in code using X?
No, it shouldn't. Unless you're trying to use it like multiply, but no, it's if there's an error, it wouldn't be the X. It would be the fact that the compiler was not expecting an X there, or was not expecting a variable name. If you have X, if you just have something where the first time X appears in your program, the first time it appears, it's on the right side, like in this case. If you just put this there, then that'll cause an error. Well, that'll cause an error because X hasn't been defined yet. See, I mean, to define something, I mean, things that are on the right side have to be defined. And if it's a variable, then somewhere up above, this X is going to have to be on the left side because you're defining it.
Okay.
So that could be what happened. Well, that could be what's happening. If you just type this in, then yeah, it's going to be an error because this is undefined. It's also going to be an error because the I is undefined also. You're trying to use it.
Thank you.
All right, good question. All right, so here's an example of you're just modifying something. So you've got this list, and okay, and it's called My Teams, and then you're going to create another list that is exactly the same as My Team. So now you have two lists, and then on the My Teams one, you're going to change the index 1. In other words, heat. You're going to change that to Lakers. Okay, and then what this is supposed to show you is that did both variables change? Okay, let me run this. Oh yeah, a shared reference. Okay, this is the one where you see, this is unique in Python. This is how you do it if you actually want to create another copy. This does not create another copy. This just gives, this list now has two names. It's got this name, and they both refer to the same list, I think. So let's run this and see. Yes. Okay, so that's how that works. So you're creating just another label for the same list. This one, however, actually creates another copy. Yes. So then when you do this thing, you are only doing it to My Teams. You're not doing it to your teams. All right. And here is an example where here you're you aren't if you're doing this equal sign with elements, does this bind? Yeah, no, it doesn't. So that puts that there. Yes. Rinse it out. And then it creates a new variable, and okay, it does. Oh. Okay, well, according to this, if you did not do this, but instead you, this actually causes the separation between them. It would be interesting to see that, see what time is it. It's not too late. I'm gonna just try to run that. So let me open up my editor. And I'm going to put this in there. And I'm going to save it as test.py. And let me run this just to see if it works like it says. cd desktop py test.py. Okay, it does that. Now I'm going to say I'm going to do this. Fave color. So I'm going to print both those things. Okay, so that's turquoise. Now I'm going to, instead I'm going to do, I'm not going to do that, but I'm going to do colors 2 equals something different, orange. And then I want to see if that changes fave color. It did not change fave. Oh, no, it did not change. It did not change fave color. Right. So fave color stayed what this was, and then this changed. So I don't think this is accurate, because when this thing executed, this said that this was pointing to that. So then I tried to change this, and that should have changed that. This should have changed along with it, because fave color was still another name for this. So anyway, let's see. Let me run this real quick again. Okay, now, see, that points to blue. Okay, and this second fave color assignment actually breaks the link, but that's not right, because if that were the case, then fave color is still pointing to colors 2. I changed colors 2 to orange, and so fave color should have changed to orange, because of this. And it didn't. It stayed blue. So anyway, all right. You know, I question this. Are strings such as no, this is a comment. Yeah, that's a good question. yeah. Anything starting with this hashtag is a comment, and so you can have comments in the beginning. If a hashtag starts at the beginning of a line, then the whole thing is a comment. But you can stick comments along the way after a statement, and so from here to the end is a comment. And in fact, you're encouraged to do that. You should like you know, tab them out, and so they all line up. And that's if your code is kind of confusing, or can get confusing. Anyway, all right, great. So you can. I'm not sure what these answers are, not because of what I just did, because of what we just discovered. All right. So here's a challenge. You've got user values. I wonder if this is bugging me. I'm going to try my other Python. Oh. All right. All right, so here we have user values of that, and we're just going to print them out. Okay, that's great. So let's see what this is. User values of that. What do we print out? Copy, paste. Yes. User values 2. So we're changing this one by adding 1 to it. So it's going to be this except this is going to be 8. And I better put that in there. Oh. Okay, very good. Okay, anyway, you can do the rest of them. Okay, what's this one? Modify short names by deleting the first. Okay, short names is a list. Okay, all right. So by deleting the first element and changing the last one to Joe. Okay, so if the sample input is Gertrude, Sam, Anne, and Joseph, you're gonna. It looks like you want to delete Gertrude and change the last element to Joe. Okay, so from Joseph. So here, user input is you read it in and then you split it. So you read this in, then you split it, and you can say the first element. First of all, we can delete the last element. Well, it doesn't matter. Okay, so first let's delete the first element. Delete short names of 0. Okay, and then I'm going to change short names of the length of short names -1. So that's, I want to refer to or reference the last element in short names, and I want to change that to just a Joe. So it would look something like this. Let's see. Let's try this. Copy, paste, and run it. And I'm supposed to enter in, Gertrude, Sam, and this one. Copy. There you go. It didn't like that. I'm going to do, I'm going to type those names in. Gertrude, space, Sam, space, and space, Joseph. Oh, I wonder what I'm doing wrong. Short names. The problem. Oh, I know the problem. I'm using the wrong Python. There must be a huge difference between Python 2 and Python 3. I wonder what it is. See if this works. No, I don't know what the problem is. Anyway, so let's do the right version of Python. Okay, there. And it got rid of Gertrude, and it changed Joseph to Joe. Okay, so looks like that will work. Okay, list methods. That might work, Mr. Liu. All right, just try it. Okay, so some list methods here is here's one, adding an element to the end of a list. So that's just one element, it looks like. This is adding all the elements in X to the end of the list. So this is when X is a list like this. And here you're inserting X into at a particular place. You're inserting X at a particular place. And it's the place just before this, whatever that index is. So I guess if you wanted to insert it in the very beginning, before anything else, you would do 0. All right. So removing elements, you can use this remove method. You can use this pop method, which removes and returns the last item in the list. So this is gonna, if you do this, that 14 is gonna be returned, and it's actually gonna remove it. So it removes the 14. The list gets, like that. And remove removes the first item, or no, it removes. Oh no, it removes. Yeah, the first item with the value X. There could be more than one 8. Okay, so this is a list. A list can have more than one element of the same value. Okay, that's not true of the set. All right. So these are other ways of removing elements, and then you can modify elements like all together. This actually sorts the list. So this is a method that operates on the list itself. So the list changes, and same with reverse. Reverses them. So it makes them in the reverse order. And then there's where if you actually return the index of the first item in the list with the value X. So this searches the list for X, and then if there's one there, it returns that index like this, and this counts up the number of elements in the list. Oh, no. This counts up the number of times X occurs in the list. I wonder if count, oh no, that'd be len. Len is what tells you the length of the list. Okay, all right. So here's some examples of using those methods. They're very similar to the string methods, so that's it should be pretty straightforward. You can guess what they are. Okay, in this little example here, what is it? A writer can enter a name to find the current position in line. A writer can enter a name to remove the writer from the line. Okay, so are we supposed to modify this thing? Oh, we're supposed to write code in here. Well, let's see. First, we're creating a blank list called line. It's going to be a line of writers, and then there's going to be track number of VIPs at the front of the line. Okay. So you're going to be able to type in a 1 to reserve a place in the VIP line, dispatch riders, print riders, and exit. What does dispatching riders mean? Printing them out or removing them. All right. See, I'm not going to do this for you, but I'll just tell you how I would do it. Okay, so 5 must be to exit. Okay, so we have a loop, and the input is either going to be 1, 2, 3, 4, or 5. It's going to ignore anything else. It's just going to say it's unknown. So if it's so if the input is ever 5, then it's done with the loop. Okay, we're done. Otherwise, if it's 1, it adds a rider. If it's 2, it adds a VIP. Adds somebody onto the VIP list, I guess. Behind the last VIP in line. Oh, okay, all right. I see what that is. If it's 3, we remove the last riders per ride. Oh, is there a riders per ride? Oh, 3. Okay, removes 3 of them. This one, prints the riders. Oh, prints the number of riders waiting in line. Okay. Add a new VIP. So we actually have. So the number of VIPs is actually going to be an index. See, let me put this down here. Okay, so it is names. We are storing names. Okay, so I'm going to take this program and put it over here. And this is what input looks like, I guess, huh? One. Can I make this bigger? No. I'm going to copy this. Copy. And this is the data. So I'm going to do something like, okay, so this is a comment. This is the way you can have a multi-line comment. And this is just the input. I just want that up here so I can refer to it. And this is my menu. And apparently I can run this right now. What does it do when I run it now? It says a bunch of fix me's, I guess. Okay, so I entered a name. Okay, I entered a number 1, and then it says this, and you type Frank, and then it says enter a command, and you type 4, and 4 says to say how many people are waiting, and it says 1 person is waiting, and it's Frank. And then you enter a 1 again, and you enter Bob, and 3. Okay, so that's how this works. And so it doesn't. Okay, so now the the VIPs are going to go in front. So so you can think of this number of VIPs as the index of where you would put the next VIP. Okay, so it's so the num VIPs is actually, let me get a whiteboard here. So let's say you have, let's say you have num VIPs equals 0. And let's say in your list you have Bob, Frank, and num VIPs is 0. So that means num VIPs is, you can think of it as it's pointing to the first place that you would put a VIP if you got a VIP, and it's a 0. This is 0 and this is 1. And so let's say then you want to reserve a place in the VIP line, and let's say that person's name is I don't know, Anne. Okay, so you would put Anne at index 0. You would insert Anne at index 0, and then you would increment this. So this becomes Anne. That's not an A. Anne, Bob, Frank, and num VIPs becomes 1. So so now num VIP, you can think of num VIPs as pointing to Bob, because Bob is the first Bob is first in line of the non VIPs. And so if some other VIP comes in now, you would stick let's say it's Betty. So Betty would go there, and Bob and Frank would get pushed down. So that's how you would insert that's how add VIP would work. Insert the VIP into the line at the position of num VIPs. Don't forget to increment num VIPs. So yeah, see, so you have to insert it. You insert it at position, insert Anne at position 0, and then you have to make sure you increment the VIPs. And so that insert, so you want to insert by pushing everybody over, I guess. What is the appends inserts? Yeah, here. So you would use inserts. You would use the insert this is num VIPs, and this is the name of the person that you would insert. So it would be, I might as well do one of these. Let's see. So let's do 2, and so I'm going to say oh, this. Start with this. Oh, let me just copy this whole thing. And I'm going to do this. And instead of I'm going to do insert, and it's going to be at num VIPs. And then I'm going to, I got to make sure I increment num VIPs. And then how do I print out the line? Oh, I do, I use 4. Okay, so if I do, I have no idea if this is going to work. Oh, tab error. Where was it? Okay. What's this going to do? It's going to really mess me up, I bet. Oh yeah. All right. I didn't mean to do that. Let me just. Can I? I gotta fix my editor. All right. So I'm gonna enter in Bob and Frank. So I'm gonna do 1 Bob. Okay. 1 Frank. Now let me do 4. Okay, Bob and Frank. And then I'm going to do 2 Ann. Okay, now I'm going to do 4. Ann's the first. And then I'm going to do 2 Betty. And then I'm going to do 4. Okay, there, yeah. So Betty got added in the right place. And I don't need to have this fix me anymore because I've already fixed it me. Make it a comment. All right, so anyway, you can practice writing the rest of them. Removing riders for removing riders per ride, all you have to do is do the remove pop maybe in front of the line. Remove first item from the list value. No, not that one. Remove and return item at position I in the list. So yeah, this is what you do here. You do line pop 0, and you pop as many times as the number of riders per group. So you would pop it 3 times. That's how you would remove the riders from the front of the line. You also better check to make sure that if you're popping people that that are smaller than what the number, if the index is smaller than num VIPs, then that means you're popping a VIP. And if you're popping a VIP, you got to make sure that you decrement, you subtract one. You know, you pop off all the VIPs, and then so if there's two VIPs, you'd pop off those two VIPs, and then you'd pop off one of the regular people. All right. So anyway, so you can work on that. Okay. Here's sort the list in reverse alphabetical order. Well, this is easy. You just first you sort the list, and then you reverse the list, right? I mean, remember those methods up here? First you sort the list, then you reverse the list. That's all you got to do. Okay, so that's pretty easy. Iterating over a list. Okay, so this is how you iterate over a list. You know, you just you have a list of stuff, and it's ordered. You know, it's got an index order, and so this takes each of them, you know, one at a time, and you refer to it by this variable name here. So so like for example, you know, let's say you type in a bunch of, you know, you enter some numbers, and then you know, and you separate the numbers by space, and then you do the split, and you end up with a list that's got these numbers in them in order. Okay, those numbers in order. And then this is going to loop through the list, and with each iteration it's going to do this, and token is going to be the next one in the list. So token is going to start out as 203, then it's going to do it again as 12, and then it's going to do it again as 5 and 800 and minus 10. And so this is going to so this is going to append token. Let's see. Okay, when we do the split, these are strings, and here you're creating another list, but instead of being strings, they're actually the numbers that they are, because that's, you know, you take the you take the integer, you convert it to an integer, and then append it on. Here's another way of doing the same thing, where you're just going to have this thing called index, and it's going to go from 0 all the way up to the number of elements in the list, minus 1. And so here you are referencing, you know, each of these elements, you know, by its index. So Aaron asked about when is token used in code. Again, you know, token, when you are when you're writing a compiler that analyzes the program, it actually breaks all of your little things up into what are called tokens. That's the common terminology. And so I think you might be referring to that. But in this case, a token is just a variable name, and it's singular. It's singular of tokens, and tokens is all the tokens. And I mean, this could be, you know, in this case, it's these numbers. But you know, we could be talking about, I guess we could be talking about tokens as tokens you use to ride the subway or something. So here, this could just as easily be T or I or something, or X. And so for this loop here, if this is X, then this would be X, and X would, the first time the loop goes through, X would be, the string 203, and the next time it's 12, and so on. All right. So here, as I said, we're referencing each of these. These are like tokens, except for their number value. This nums is the same as this nums, and this prints out the value. And then here we're actually determine the maximum even number. So here we're looping through all of nums. Nums is this list, and tokens is the list, but they're strings. Okay, they aren't integers; they're strings. They could just as easily be letters, and it would be fine. Nums, though, is supposed to be integer numbers. So this is a list of numbers, and this is a list of strings that represent numbers. You can think of it that way. And here we're looping through the tokens. I mean, we could do it either way. We're just, but here we're looping through all of these after they've been turned into a list. And here we're looping through, all of these, which we built here. So we're looping through those. Here we do it by index. It's just a different way of doing it. Here we're doing it by, by each element or each integer in the list, and we're testing to see first if it's an even number, and if it is an even number, it saves the biggest one, and it goes through some sort of, starts out with this thing equal to num, and so on. Anyway, using a variable to keep track of value. Well, yeah, okay, well, there's different things and ways of doing things. How many odd numbers are there? With this num, I see. Okay, anyway, you can look at this. There could be index errors. Iterates over a list and provides an iteration counter. The program above uses the enumerate function. This is the index, and this provides two values each time, each loop. It provides both the index and the value at that index. So that's probably useful for some things. Built-in functions, true if every element in the list is true. So true if every element true is any element that's not equal to 0. If it's equal to 0, it's not true. It's false. If it's equal to 0, it's false. If it's equal to anything other than 0, it's true. So that's why, and this just tests if they're all true. And so this tests if they're all true, and these are all true because not one of them is equal to 0, or none of them are equal to 0. Here though, there's one that's equal to 0, so this is false. So they're not all true, so that's why this output's false. True if anyone is, this is any, if any of them are true. This gets the maximum of the list, this gets the minimum, and this gets the sum where it adds them all up. Nice little methods there. Okay, so here you can figure out how to do the total points by summing. You can get an average points per game by taking this divided by this, plus this divided by this, plus this divided by this. Is that right? Yeah, you add all that up, and then you divide by the number of games. Best scoring years. Are these years? Oh yeah, they're years. So yeah, you do max, find max. And here you do min. So anyway, okay, this tests your understanding of these methods. And here's a challenge. Write a loop to populate the list user guesses with the number of guesses. The variable sum, or num guesses, is the number of guesses the user will have, which is the first integer. Okay, so this says that the user is going to have 3 guesses, and you're supposed to append these onto creating this list. Is that all? Okay, well, I mean, I guess we got a loop. I guess we have to loop this many times, and each time we're going to ask, and then we append it onto this. So it must be like for I in range of num guesses. No, there's good. Num guesses. User guesses append. Oh, gotta ask where it is first. G for guess equals input. It's a number, I bet. Int input. I don't ask anything. I just expect the user to know what to put in. And I'm gonna do this. G. Something like that. Sure. Yes, I'm sure that's right. Is that right? I think so. Okay, so you can try that out. So you can try that out. All right, next one. Some extra credit. Some extra credit. Okay. Assign some extra with the total extra credit received given list test grades. The full credit is 100, so anything over 100 is extra credit. For a given program, some extra is 8 because that. Oh, I see. I don't recall covering this. Function, but it reads in the user input. First it reads in this string, and then it creates a list, and for each of these, this is a list. This right here is a list. This is a list of strings, and this maps each one of them into an integer and makes it a list of integers. So anyway, it gives you that. And so test grades is this list of, looks like this, except for it's actually numbers. This is a big string. So, and then I guess we loop through, and if any of them are over, if any of them are over 100, then we that's extra credit. So I don't know. For grade in test grades, well, I got to set sum extra equal to 0. For grade in test grades, if grade is greater than 100, then sum extra, add the grade minus 100, I guess. Yeah, this should work. I think this should work. You don't need to do that. I don't think you need to do that. All right, let's see if I'm going to test it. Oh, did I get it? Oh, okay. Oh, great. That's wonderful. All right. So it evaluates this and it adds it to this. That's what we wanted that to do. All right. Hourly temperature reporting. Write a loop to print all elements in hourly temperature. This is a, okay, so this is a list separated by this character, surrounded by spaces. So if this is a list, we want to print this. Boy, they make it so hard. For I in hourly temperature, for every I, for every T, for every temp in hourly temperature, I'm gonna make a do I put a space followed by a space and a new line? All right, I'm going to do this. I'm going to do this. I hope it's okay. Okay, I hope I can do this. String, outstring equals hourly temperature pop 0. String. Plus. Okay, now for the remaining temp in hourly temperature. Oh no, I'm gonna put a. Okay, outstring. Append onto outstring. This space dash greater than space plus this. And then when I'm all done, outstring, add a space onto it because it says it has to have a space at the end. Okay, and then I'm going to print outstring. Okay, I'm going to run this over here. Save this and run it. Put this over here because this is what I. Okay, this is okay. So did I save it? Save it, and then run it. Oh, I got to exit. What's exit 5? Yeah, okay. Run it. Okay, now what it wants to see is this. So 90 space 92 space 94 space 95. Enter. What happened to the 95? I don't need to pop this, do I? Well, it looks like I'm, okay, so I'm going to do this instead. I don't use temp anywhere. So this is just an index. Index in range, length, of, yeah, this should work. By the way, did I? Yeah, okay. All right. So let me just try this. All right, I'm gonna try this, see what this does. 90, 92, 94, 95. Yeah, look. Now the question is, if you paste that into here, or I guess paste, oh yeah, no, if that's this, will it work? I don't know, you can try it. Okay, let's see, list games. Yeah, the book solution for that last one's pretty amazing. It's quite a bit different than mine, but anyway. All right, what is this? List games. Is there anything here? Just list games. The following activities can help one become comfortable with iterating through lists. Challenge yourself with these list games. Start. What am I supposed to do? I'm supposed to find the maximum in the list, huh? Okay, store. Next, 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 store, next, next. Okay. If a negative value is seen, click increment. Try again to get your best time. When a negative value is seen, click increment. Start. Next, next, increment, next, increment, next, increment, next, next, increment. Anyway, that looks like fun. Manually sorting the largest, move the largest value to the rightmost position of the list. If the larger of the two current values is on the left, then swap the values. Try again to get your, oh, this will be fun. Okay, so I'm supposed to swap in a way where the largest value is going to end up at the top. All right, 66, that's good. I don't need to swap that, do I? I do need to swap this. I don't need to swap that. Oh, we need to swap that, all right. Swap that. Swap that. Is that right? Yeah, I guess it is. Okay. Anyway, this is the basis of sorting. So, and this is how a bubble sort would work. Okay. Next, we go through these and keep on swapping with the largest one. So what would happen in the next round is the 66 would end up here, and then we do one less, and the 59 would end up here, and then we do one less, and the 10 would end up here, and so on. That's a bubble sort. Anyway, it's 429, and I didn't get very far. Let's see, how far did I get? I got up to list nesting. Okay, so list nesting makes two-dimensional arrays. So it's basically you have lists of lists, and then so I'm not going to go through this, but you have lists of lists. So here's your list, and it's made up of two lists. Okay, so when you have lists of lists, it's like you can think of the outer list as like the rows, and then inside are columns. So it's kind of like this. Anyway, like this, where this is the row, and the second one is the column. So anyway, I think I'm done for today. So we will continue this. See, is like next week Thanksgiving week? I think it is, right?
Yes.
Okay, so I guess we'll meet on Tuesday, but not on Thursday, I guess. Is that right? Yeah.
Yeah.
Okay. Well, great. So I will see you. I'll figure out how to speed it up a little bit, I guess, and I'll see you on Tuesday.
Thank you.
Thanks for watching.